Okay, we're starting Unit 4A. We're going to start off with just determining absolute and relative extremes, or in other words, maximum and minimums depending on locality. First and most important critical point would be, get it, critical, would be where you are located where you find the derivative is equal to 0 or it's undefined. I'll explain why it has to be both with illustrations in a minute. Then there's two types of extremes. There's absolute extremes. I mean, great, we live on Western Hills. It's a local extreme, a local maximum in height. However, we're not the global max. We're not the absolute max. That's the difference between an absolute extreme and a relative extreme. For absolute maxes and mins are located at endpoints. We just need to identify the endpoints, not only where they're at, but what their value is, and at the critical points. And you'll see an illustration of that in a second. We need both, because that's where the extremes can live. Simple example would be a function like a parabola. If it's closed, pardon me. So if I have a parabola and I close it on ends, we have a couple important features. One, we have a maximum located here. Not only is it locally a maximum, it's also an absolute maximum. It's qualified as both because all over the place it's still the absolute maximum. Now these two values here are both minimums. This one is simply a local one because it only occurs, it's only the minimum if you only pay attention to just the region in here. But we're looking at the whole closed interval, so that would mean I need to indicate it as solely a local, and the minimum there, that would be considered the absolute minimum. It's also considered a local, but it's also an absolute. All absolutes are locals. Relative extreme. So let's give you a couple more illustrations. Let's look at this function. Again, x squared. Let's be very specific on -1 to 2. First thing is you identify the endpoints. Step 1, endpoints. Your endpoints are given to you as x equals -1 and 2. Now what we need is those values. The x values only tell us location. So if I plug that in, I get 1, and I get 2, I get 4. Now the next thing you need is crit points. Crit points are where the derivative is equal to 0 or undefined, as shown above. So I need to take its derivative, and let me do this for you because I know it's complicated. So take the derivative, and we need to know when that's a 0 or undefined. Well, 2x is always defined, so we can only find where it's equal to 0, and that's located at x is 0. So I have a critical point located at x equals 0. Its actual value is when I plug it into the function, which happens to also be 0. So given my three values that I currently have, I've got a 1, a 4, and a 0. Because this function is closed, I can automatically tell you which one's the absolute max. This is right here is the absolute max because it's the largest number. Is 4 at x equals 2. That's the way you verbalize that. My absolute minimum is 0, and it is at x equals 0. This guy here, this one's just a local minimum, and it's located at -1. And my illustration I've already shown you to do it again, but it's the parabola is located, and I went from 2 to negative 1, and that's what you see on the curve. Giving you an additional example, I'll erase that one. I'm going to give you additional example would be x to the 2/5 power. And I'm going to give it on the same interval. Now you're saying, okay, Schroeder, I know what that is. I'm thinking already, like you told me to. Clearly that's a birdie or a cusp. It's even over odd power. It's got to be a cusp. The cusp curves to 0. So I already know what this looks like, and we can visualize it in a second. But process would be, step 1, you need your ends. And you have to dig really hard to figure these one out, because clearly they just give them to you. And we also need their values. We know the end points are located at negative 1, 2, but their actual values are negative 1 to the 2/5 power, means the 5th root of negative 1 is negative 1 square, which is 1. And then I'm plugging in 2 and 2. Wow, I picked a beautiful number. Let's cheat. I'm going to change my closed so I can actually do this one. How about 32? Ah, shut up. It's no big deal. You'll see why I had to do that in a second. 32. Oops. 32 to the 2/5 power. See, that means the 5th root of 32, which is 2, square, which is 4. Okay, so I have my ends and I have their values. I also need the crit points. Now, you'll understand this more when I show you the illustration, but I have to have this derivative where it's undefined. Because, see, I don't like the way this is written. I already took its derivative, but when I'm evaluating, I want to rewrite it like this. So I'm going to find my crit points. I'm going to set this equal to 0, which means 2 equals 0. That doesn't exist. So it's never equal to 0. But if I want it undefined, I set the denominator equals 0. If I do that, I get x equals 0. That means my birdie's at 0. It also means I have a critical point at 0. And it's critical, all right. Go ahead and plug that in. You need its value, and you get 0. Excuse me there. I had to do that. Now, if I draw the picture, I'm going to go all the way out to 32. Let's picture that for a second. And then over to negative 1. So there's my birdie. And you can see my maximum occurs right there. Right over there. Here's my max. That max is clearly at 4 at x equals 32. That's my max. Absolutely. My absolute minimum is there. Even on the picture, you can see that. My minimum's located there. Well, if I didn't consider critical points to be undefined, where the derivative is undefined, I would be missing this point, analytically speaking. So this 0 is my min at x equals 0. And that's just a local, and that is, of course, 1 at x equals negative 1. Now, just to make so what allows us to skip a lot of steps in the process that I'm going to show you in later sections is this thing called the EVT, or extreme value theorem. It says I am guaranteed, as long as it's continuous. I mean, we've already talked about how to determine something continuous, and we close it. In this case, they're going to have to define it as closed. You must have an absolute max and a min, no exceptions. So when you get the extreme value theorem, you are set to go. Here's an illustration. Again, sorry about that. Am I guaranteed this is absolute max or absolute min? Well, I have to first decide, is this continuous? Well, I don't know. I don't know what f of x looks like, but I certainly know this part's continuous. It's a poly. I also know this part's continuous. It's e to the x. It's continuous. And if you multiply two continuous together, you get continuous. So the first thing that I have to do is I have to state f of x is continuous and closed, because they closed it for us. Oops. So it's continuous closed. Since it's continuous and closed, yes. Therefore, by EVT, there is an absolute max and absolute min. Find the local extremes on the domain of f of x. So I need my derivative on its natural domain. That means I don't want to restrict it. So let's take the derivative real quick. You have a product. Don't forget f times g, and f is a chain rule. You got u squared, so 2u. Sorry, 2u times the derivative of u times g plus u times the derivative of g. Now, I've told you a million times how important this is. Now remember, I want to set this equal to 0 and or undefined. And if I'm setting it to 0, guess what form I need it in? Go ahead. You can say it out loud. Your parents won't laugh at you when you're sitting at home yelling out the factored form. But clearly you have two terms. Therefore, it's not in factored form. They're common terms, or sorry, common factors are -2 and e to the x. It remains, the first one, see these are gone, is a 2 and a 1, or just 2, plus, and over here I've got one of these gone and one of the, this is gone, and all I got left is an x minus 2. So if I put it all together, I get x minus 2 e to the x times x equals 0. Now, once it's in factored form, how delish? You just set each factor equal to 0. Because one of them has to be 0 and for the whole, all the product to be 0. So I have one crit point at x equals 2. So my crits. Step 1 ends. We don't have any. Step 2 crits. We got 1. Uh-oh, how to get rid of that? Oh, yeah. ln 0. You ln both sides to get rid of e. Oops, that's poop. And there's my other one. So I have two critical values. Start off step 1, endpoints. Don't have any. Step 2, crit points. I've got 2. Step 3, you can do your extremes. You can determine what's max or a min. But it just said find them, so I'm going to do that. It didn't tell me to identify them as local maxes or mins. So 2 is 2 at 2. Hello, f2. 2 subtract 2 square e to the 2 is 0. F 0 is 2 subtract 0 square e to the 0. 2 squared times 1 is 4. So I have two local extremes. Now we need to kind of need that for the next part. Next part says find the absolute and relative extremes for f of x on a closed interval, which means I'm guaranteed to have an absolute max and absolute min. So right now I've already need step 1 ends. Let me do it for you. Oops, it's -2 and 3. My crits. Step 2, crits. Well, I've already found them for you, and this showed you how to do that. I got 2 of them. Step 3. Now, step 3, we're going to do intervals, but here, since it's guaranteed, I don't need to do my third step. I'll show you in the next units where we have to do these interval things. Here, I do not need to do that. I simply have to determine which one's the highest and lowest values. So I need the value at -2, the value at 3, the value at 2, the value at 0. Well, we've already done the 2 here. This one's 4, and that one's 0. F3, if you evaluate that one quickly in your head without crying about it, you're going to get e to the 3. I don't know what that is, but it's something like a little less than 27, so like 25. Because remember, e is 2.72. -2. I plug in -2. I get, I don't know. What do I look like? A magic man? Just going to pound that out in my head and just know it? Well, of course, you get 16 e to the -2, I think. But that's just 16 divided by e squared. I don't know what that number is, but it certainly isn't a very big number. E to the 3 is about, I'm going to guess about 25. You can check it in your calculator. This guy, I'm going to guess it's about 2-ish. Because here right now, all I have to do is find my absolute maxes and mins. Clearly, that one's my largest. So my absolute max is e to the 3 at x equals 3. My smallest number, even though this one right here is a small number, it's not smaller than 0. That's my absolute min is 0 at x equals 2. Yes, the verbiage is important. That means this one's got to be relatively smaller, so it's absolute. It's not an absolute. It's a local. It's not absolutely anything. Local min, or actually that's a, yep, nope, it's a max. It's a min. Local min at x equals -2 is 16 over e squared, and that would be a local max. Please do the bookwork, and see you mañana. Hopefully I won't be coughing, and again, I apologize for all the noise.